Welcome to solverfy.
For this problem, in question 1, we have that the numerator, seen in the z-test, the t-test, and the ANOVA test, represents the difference from expected value, or from the hypothesized value. The denominator represents the variability of the statistic. So we have that essentially the z-test, t-test, and the F statistic for ANOVA tell us how big is the difference relative to the variation. Then for question 2, one thing that I'll note here is that the variability of the statistic is the one that is going to be affected the most by experimental design. If there's a difference from the hypothesized value, that should be something that is reflective of some underlying fact. It's a difference from the expected mean value of the population. But for the variability of the statistic, that is something that we oftentimes can control very directly by controlling our sample sizes. Then for question 2, let's see here. We're asked for the difference between the goodness of fit test and test for independence. So the logic, when we do a goodness of fit test, we're trying to see, are the proportions of are the proportions of results distributed as expected? So that could be when you are testing the hypothesis that there's a uniform distribution. But then again, you can also use a goodness of fit test for testing to see if something is normally distributed or exponentially distributed, and so on. The test for independence is essentially testing, are the two factors related? We can think of the goodness of fit test as a special case of the test for independence, because if you have categories A, B, and C, and we have the hypothesis that there is no difference between them, then we want to see, is there any relation between frequency and the category? But when we're doing a test for independence, we often can have more than just one value along our rows. We can be testing to see if level of education is related to how many pets you own, and something like that, where the goodness of fit is no longer meaningful. Instead, you're trying to see if those two categorical variables are related. And actually, that's also another good point. The independence test is for two categorical variables. The GOF test is for a Basically, it's a single categorical variable.